Hey there, it's Mrs. Hall again. Alright, so I am looking at page 18 in your PACE. I'm looking at number 6, so it says to solve and to simplify. Alright, so notice that on the examples in that pink box, when you have a negative exponent, to bring it to a positive exponent, you have to flip sides. So the phrase that we like to say is flip sides, change signs. Alright, so flip sides, change signs. And when I say flip sides, I'm talking about a fraction. So first and foremost, I'm going to go ahead and put this over 1 because I can make any whole number into a fraction by putting it over 1. Alright, so now if I bring my 6 to the negative second power to the bottom, it then becomes a positive 2 now. And we know what 6 squared is, so when I bring it to the bottom, I change the sign so my negative exponent becomes positive, and I hold my spot on top with a 1. And then 6 squared is the same thing as 6 times 6, and 6 times 6 is 36. So 1 over 36 would be your final answer. So again, we flip the sides. My negative exponent became positive when I did that. I changed the sign. And then I simplified by saying 6 squared, which is 6 times 6 is 36. So for number 8, notice how the negative is inside the parentheses. Okay, when it's inside the parentheses, your negative is going to stay with a 3. If it's not in parentheses like this one is, it's going to be different. So let's look at number 8 really quick. Alright, so again, I can put this over 1 to create a fraction. Now I'm going to bring this entire thing to the bottom, okay? So now I have negative 3, and when I flip sides, I change my sign of the exponent, so my 4 becomes a positive 4 now. And then I hold my spot on top with a 1. So now we simplify, and this is equal to negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Again, positive 9, and 9 times 9 is equal to 89. And again, on the top, we only have a 1. So this here would be my final answer, 1 over 89. I'm sorry, 81. I don't know why I wrote 9, 81. 9 times 9 is 81. Alright, looking at number 9. This time, the negative is not in parentheses with the 9. Therefore, the negative is just going to float off to the side, and it's going to stay there the whole time. Alright, so think about it as this is just together. So my negative is going to stay outside my fraction. My 9 is going to come to the denominator. And when I flip the sides, I change my sign to a positive 1. And I hold my spot on top with a 1. So now, again, I keep my negative. I have 1, and then 9 to the first power is just 9. Therefore, my final answer is going to be negative 1 over 9. Alrighty. Now, also it talks about in the pink box that any expression to the 0 power is 1. So again, anything to the 0 power is 1. This is very important to know, so please know that. So looking at number 17, we have 2/3 to the 0 power. Anything to the 0 power is 1. And that's all we do. 1 is our final answer there. Alright, looking at number 19. I forgot my exponent for 19. It should be to a negative second power. I apologize for that. Alright, so now when we have a fraction that's raised to a power, that power goes to both the numerator and the denominator. So now I'm going to look at that as negative sorry, just 1 second. 19. I'm sorry, I was looking at the wrong one here. Okay. Yes, page 18, number 19. Awesome. So I'm going to have negative 3 to the negative second power over negative 7 to the negative second power. So my negative 2 went to both my 3 and my 7. And I kept the negative sign with both of them. Or we actually only need it with 1, so I'm going to put up my 3. Alright, so now when you, again, to make our exponents positive, we flip sides and then we change the sign to make our exponent positive. So that being said, my 3 is going to come to the bottom and my negative exponent becomes a positive exponent. So this came down, and now this time my 7 is going to come to the top. And then again, the exponent becomes positive. So here we have to flip both the top and the bottom. They switch places. So 7 squared is equal to 7 times 7, and negative 3 squared is equal to negative 3 times negative 3. 7 times 7 is 49. Negative 3 times negative 3 is 9, and then we can simplify. So how many times can 9 go into 49? It can go into it 5 times, and 5 times 9 is 45. So if I take away 45, I have 4 left over. So 5 and 4/9 is your final answer. So this is how you would do the rest of them on page 18. Again, don't forget, anything to the 0 power is 1. Very important to know that, okay? Looking at page 19 now. Looking at page 19 on number 4, in the directions it says if A is equal to 1 and B is equal to 1/2, C is equal to -1, R is equal to 1/3, and S is equal to 1/4. Substitute the numerical value for the variable and solve. So we're going to take the numerical value that they give us according to the directions and we're going to plug it in. So B, according to the directions, is 1/2. So now I have 1/2 to the negative second power times S, and again, according to the directions, S is equal to 1/4 raised to the negative first power over 2 times B, again B is still 1/2 to the negative third power. Looking at this might be a little confusing as to how to switch everything around, so my first suggestion is before we simplify this, I'm actually going to go ahead and cross this out. I apologize for that. Let's make our exponents here positive before we plug in our numbers. So I'm going to bring this B squared down, this S to the first power down, and then this B up. So now I have 2 times B squared, because this one the first B on the top came down. My S from the top is going to come down as well. Again, our exponents become positive. And then my B to the third power came up top. All right, so now let's go ahead and plug in our numbers. So now B cubed, B is 1/2. 2 times, again, B is 1/2. And S is 1/4. Alright, so 1/2 squared, I'm going to go ahead and bring that up here. Cubed. 1/2 cubed is 1/2 times 1/2 times 1/2. 2 times 2 is 4. 4 times 2 is 8. So our numerator now becomes 1/8. And our denominator, 1/2 squared, is equal to 1/2 times 1/2, which is equal to 1 over, and 2 times 2 is 4. So this part here is equal to 1/4. So now I have 2 times 1/4 times 1/4. 4 times 4 is 8. So now I have 1/8 over 2 times 1/8. And 2 times 1 is 2. 2/8. So now we're going to do keep, change, flip. I'm going to keep my 1/8, change it to multiplication, and flip and have 8 over 2. My 8's will cancel. 8 goes into 8 one time on both sides. So now 1 times 1 is equal to 1, and 1 times 2 is equal to 2. So your final answer will be 1/2. Again, so I do apologize for that. Be sure that you first simplify everything to have positive exponents before you plug in numbers, because then it would have been a little bit crazy to picture the fractions within a fraction and all kind of stuff. So make sure you do this step first for me, please. Looking at number 7. All right, so when we have a power raised to another power, we multiply the exponents. So if you think about it, 5 squared to the 4th power is equal to 5 squared times 5 squared times 5 squared times 5 squared. So instead of writing all of this out, when we do it this way, we know we can add them. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, which would give us 5 to the 8th power. Instead of doing this step here, we can simplify by just multiplying our exponents. So 2 times the 4 is equal to 8. All right, so for number 14, we have z, and then 5 times negative 9 is equal to negative 45. And that's all you do. All right, and then a, there is no exponent on the a. If there is no exponent, there is an imaginary 1. So 1 times 9 is going to be 9. So a to the 9th power. And that's all you're doing. You multiply them, and that's it. All right, now let's look on page 20. I didn't set this one up at all, so let me go ahead and start here. This is book 2, page 20. Looking at number 4. They give you xy squared z cubed, all of this to the 4th power. So yes, we are going to multiply everything to the 4th, by 4, our exponents wise. But first, notice that x has an exponent of 1. Everything is going to be multiplied by 4, okay? So 1 times 4 is 4. And for my y, 2 times 4 is 8. And for my z, 3 times 4 is 12. This would be my final answer. Again, it's the same thing as page 19, except this time we have to make sure that we're multiplying everything. So let's look at number 11. We have 10a to the 6th power times b, and all of this is raised to the 3rd power. So again, everything is going to be raised to the 3rd power. All right, so now I've got an invisible 1 for my exponent for both the 10 and the b. So now I have 10 cubed, because 1 times 3 is 3. Then for my a, 6 times 3 is 18, and for my b, 1 times 3 is 3. However, since this is a numerical value, we can simplify that. 10 cubed is equal to 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. Again, it's equal to the number of zeros is our exponent. And then we have a to the 18th, b to the 3rd. And that's it there. Numbers 13 through 33 are the exact same way, except they want to have one final number at the end. So for example, on number 13, they give you 3 squared plus 3 to the 4th. They want you to know that, yes, you add them and you get 3 to the 6th, but they also want to know what that final number is going to be. So it's going to be 3 times 3 times 3. 1, 2, 3, 4, 5, 6 times. 3 times 3 is 9. 3 times 3 is 9. 3 times 3, again, is 9. And then 9 times 9 is 81. And we are multiplying each time. And then 81 times 9 is 729. They want to see this final answer. They do not want this as your final answer. They want to see 729, not 3 to the 6th power. Alrighty? So I hope that helps. If not, let me know. Don't forget, when you multiply two two numbers with the same base but different exponents, we add them. Just like we did here, we added our 2 and our 4. If we're dividing, we subtract them. And if we have a power raised to another power, we multiply the exponents. Alrighty? I hope this helps. Have a wonderful day.